Hey, Vlad here, dependency.com. Welcome to another video. In the previous video, we've seen how packages can help us split our code into modules which might reside in different files. And today we're going to see how traits can be used as an alternative for such modularization. As always, we're in the Ubuntu virtual machine and we have Sublime on the left and the regular terminal on the right, which runs SBT, which runs our code every time we save the file. Alright, so almost 6 years ago, I asked a question on Stack Overflow if traits could replace packages, and the answer was yes. I'm not going to show you the question right here because I don't want you to concentrate on that, but I'm going to leave the link down in the description. So today I'm going to show you how this can be done, and the idea is very simple. Basically, you take your top level objects like classes, object, or traits themselves, and you put them into traits, right? So you call those outer traits something module, right? So you end up with those top level traits basically, right? And then you put them all together and you mix them all into one big object, right? This pattern goes by the name of the cake pattern because you sort of have like those layers and layers and layers of traits, and you bake them in, you mix them into this one big object. And this object is also going by the name sometimes of the all-you-can-eat object, because now you have access to all the public members of this cake. We're not talking about the cake pattern today though, because for that we would need a bigger boat. We would need a really big example to see all the benefits and all the trade-offs of this pattern, right? So what I'm going to do is I'm going to have a separate video just for the cake pattern. So today we're just going to go through all the tools, all the mechanics that are required to implement the cake pattern. Specifically, by the end of this video, we're going to learn about the concept of self types, which help with the whole thing. Okay, so let's start with the example, with exactly the same example as we had in the previous video. We have a folder called words over here, right? And inside of words we have nouns. I'm just going to type it out real quick. Okay, so over here we had 3 files. The first one was called animals.scala. Inside we had a package words, and we had a package nouns. We had an object animals like this. We had a dog, dog, and we had a cat like this. Right, then we had a similar file called transport. There we go, same pattern, right? So we had package words, words, package nouns, object transport, and over here we had a car, and we had a plane. And the last one that we had was plants.scala, package words, package nouns, object plants, and over here we just had flowers or flower. In the previous video I used flowers, but it was supposed to be just flower, which doesn't really make any difference. So now in our main we can just import words like this, import words. And instead of printing out hello world, we can print out nouns dot, for example, animals dot cat like this. All right, so we have words and nouns, and what I'm going to do now is I'm also going to have a folder for verbs, and the verbs, for verbs we're going to use traits instead of packages, right? So I'm just going to create a folder called verbs like this, and over there we're going to create a file, and this file is going to be called actions, because there are action verbs, right? So it's still going to be used the package words, but it's not going to use package verbs for now, right? So it uses package words, but it doesn't use package verbs. In fact, let me do package verbs, and let me just comment it out so that it's clear, right? So over here, we could have object actions, right? And we're going to have, for example, eating, and we're going to have, for example, moving, right? Like this. So as I explained in the beginning of the video, all we need to do is we need to wrap it in a trait, and in this case we're going to call it actions module, which is sort of like a convention, and we're going to put this inside of it, right? Actions module, right? Like this. And we're going to similarly create a file called helping for helping words, and we're going to do package words, and I'm going to do again package verbs, and I'm going to comment it out like this, right? So we're going to have trait helping module, right? And inside of it, we're going to have an object helping. And inside of it, we're going to have verbs like being, and for example, did, right? And the last one that we're going to have are the linking verbs. Linking, like this, right? So as always, we have package words, we have package verbs. Then I'm going to comment out. We're going to have linking module. We're going to have an object linking. Whoops. Why did I call it the same? It doesn't have to be called the same, but it's just a convention. Why confuse anyone? So we're going to have is, which is a linking verb. I hope I'm doing this right. I hope it actually is a linking verb. Okay, like this. Right, so now we're going to go to main. And what we want to do is by the end, I mean, right now it's not going to work, but we want to have something like this. We want to have verbs, then, I don't know, for example, actions. For example, what did we have there? Eating, right? Eating, right? So now like this is not going to work because there's no, even the package verbs doesn't exist yet. So what we can do, we don't have to do it like this, but what we can do is we can abuse package objects. So we can go over here, we can create a file called package.scala, right? I'm going to do package words, and over here we're going to have package object verbs, right? And now we're going to say extends actions module, and I'm going to do it like this so that it's sort of in line with, I'm going to say with all the others basically, right? So we're going to say helping module, and this one is going to be linking module, right? And now all of a sudden this is going to work. Let's go through this real quick just so that I'm sure that you guys understand what's happening, right? So over here when we say verbs, you know, the package verbs doesn't actually exist, right? But because we have a package object where we mix in all of them, right, the verbs sort of becomes an all-you-can-eat object, right? And therefore it has access to the object actions, which is inside of actions module over here, right? In fact, let me open actions module down here, actions right here, right? So let me have it like this. Hold up. So I want to have actions over here, and I want to have the package over here, right? Like this. In fact, let me maximize the whole thing. Okay, right. So we have verbs, which is this package object. We have actions, which is this object that is inside of this trait, but because this trait is mixed into this object, we can just do this, right? So actions becomes part of verbs, right? And then we just call eating. This is how it works. It's actually really interesting because now we can also go back to actions and add the package verbs, for example. It's not going to change anything, right? Because, you know, it doesn't really matter in which package it is. Let me show you. If we go here, and instead of eating, let me do cat. So over here we're going to say get class. Over here we're going to do the same thing, right? So if we see the class of actions, now it's in words.verbs.actions module, right? And if we remove verbs like this, then it's going to disappear from here. But in our case, it doesn't really matter, right? Because we gain access to it not via the package mechanism, but in this case via the package object. Let me actually do this with the others, just because we can over here. And the linking also has it, right? So now all of them have it, and we can actually go to main and do this with the others, helping and linking. I hate it when the cursor is like right in the middle of where I'm typing, right? Okay, so it works for everything. All right, now let me collapse this back to 1, and let's go back to nouns. The nouns is down with the packages, right? Let's go to animals, and let me show you something. I'm gonna have a function called demonstrate over here, right? It's just gonna print line something, right? It's gonna print line. It's gonna say I love. So over here we can say, sorry, that was a wrong example. Okay, so over here we're gonna say a dog, or actually we're gonna say animals.dog, because I'm gonna need to copy paste it in a second, and this way I won't need to change it. A dog is traveling on A, and this is why we're here. So I want to show you that because everything is in the same package, we could have something like this, right? So animals can have an access to transport, right? So all I want to do is I want to show you that this is going to compile, right? Because transport is also in the package called nouns. Why doesn't compile? Not found value. Oh, right, animals like this. All right, there we go. Okay, so we don't actually really care what is being printed out. In fact, maybe I should turn it off. Let's just see if it compiles. Like all I care about is if it compiles, right? So let's see what will happen if we try to do the same thing in the actions, for example, right? So right over here where we're in nouns, animals. Let's try to do the same thing with the actions, because in actions we're not using packages, we're using traits. Okay, so we're gonna have a very similar thing, right? So we're gonna have demonstrate. Let me just have, let me just have more space like this. Okay, so we're gonna have demonstrate unit, right, equals, and this is where the example was, right? So over here, I'm gonna say I love actions dot eating. I forgot the S, syntax highlighting is wrong. There we go. I love eating and B. Right? Let's see if this is gonna work. Well, this actually works, but it works by accident, right? Because you know, over here we want to use traits, but we ended up using traits and packages, right? So let me remove that. Let me remove the verbs over here, right? And let me go to helping, to the same thing, go to linking, to the same thing, right? So now we're actually seeing what I wanted to show you, right? So now we're seeing not found value helping, right? Because remember, the package objects that we have is for verbs and not for words. In fact, let me open it maybe again over here. Package, this one, right? So if we were inside of verbs, as we were just a second ago, then we would have access to helping, but because of this, right? This way, we don't. So how can we gain access to helping? Well, we already know about inheritance, right? So we can try that. Let's try that. So we can say extends helping module like this, and all of a sudden it works. It is a really bad idea though, because an actions module doesn't have anything to do with the helping module. I mean, of course it has something to do because I constructed this example, right? So it needs some stuff from helping, but an action is not a helping verb, right? So let's continue with the other example. So in the animals, we said, okay, animals has access to transport. Let's try the other way around. Let's just copy that, and this is why I use the full name here. Let's go to transport and do the same thing, right? So transport and animals, they're still in the same package, so it still should compile. Let's try to do the same thing with the actions. We go to actions like this. We copy that. Now we go to where do we have? We had helping, right? Let's put it over here, right? So it should work, right? By the same, by the same token, but it doesn't, right? Because helping doesn't have access to actions. Well, let's fix it with inheritance again. We do extends actions module. Let's see what's going to happen. What you see here is, I believe, a compiler bug, right? So it says that we can do last compile colon. My hands are cold somehow. I don't know why. I can't type. It's freaking summer here. So it says stack trace suppressed. Run this command for the full output. Let's see. Okay, it shows us some weird crap about Scala, reflect, internal, and stuff. The thing is that it is actually a bug because we're using package objects, and package objects are somehow tricky sometimes, right? So let's not do this. Let's not do this. And because of that, we need to go back to main. Where's my main? Let's go to main like this. And we can just comment this out, right? Because we only care about about compiling, right? So this is what I wanted to show you: illegal cyclic inheritance involving trait helping module. So with inheritance, we can't have cycles, right? Inside of a package, we sort of can have cycles, right? An animal has access to transport, and a transport has access to animal. But if we're doing this with traits and we're using inheritance, then we can't have both. So we can either have actions depend on helping module, or the helping module depends on actions, but not both. And this is where self types come in. So first, let's revert our code a little bit. So let's not do this. I'm just going to comment this out, right? And because of this, this is not going to compile, right? So let's comment this out and let's comment that out. So now everything compiles again. So now let's go to actions and let's use self types instead of inheritance, right? So the way you do this is, remember in the video about the environment model of computation, we said that you know, classes and objects and traits, they introduce an environment, and you always have access to the environment pointer, which is called this. And I showed you that you can also rename it to something, right? And usually you would call it self, right? Self, like in Python, for example, right? Self and the arrow to the right. So this thing compiles now, right? So basically over here now, we were able to say this dot actions, for example, right? Why does this work? Well, action is not a member of object actions. Oh, no, this becomes actions, right? So if we use this, then it's referring to actions, right? So basically we can say this dot eating, right? So what we can do now is we can also do self dot actions, right? And I believe we can also do actions module dot actions. No, that doesn't work. All right, so we can do this, right? So what we also can do is we can not only change the name of the reference to the current environment, we can also sort of change the type. We're not really changing the type, but it sort of feels like it, right? So we can also say, okay, this thing is actually not only the actions module, it is also a helping module, like this, right? And you can also keep going like this, right? So if you had some, I don't know, trait A over here, you could also say it's a helping module with A, right? Like this. All right, so I'm showing you that it works on the you know, on the syntax level. And by the way, you can also keep using this, right? There's nothing wrong with using this, but somehow, unfortunately, if you don't use the type thing, right? So if I comment this out, whoops, if I comment this out, then for some reason I can't use this over there. I'm not really sure. It says something weird. Tuples cannot be directly deconstructed. Blah blah blah. I'm not really sure. Anyway. So we can use this now, and now because we use this, we don't have to extend helping module, right? Notice this thing still compiles, right? So what does this thing do? Well, basically it's just a note for the compiler, right? So this is a way to tell the compiler that whenever the actions module is mixed into something which is sort of like final, right? So if it's mixed into something that requires an implementation, so if it's mixed into something like a class or an object, basically it's only these two. As soon as you mix actions module either directly or indirectly into a class or an object, the compiler will make sure that you also mix in the helping module. Let me actually show you, because we can do it right here. Look, now it's going to say self-type words.verbs.type. So basically the type of this object does not conform to words actions module, this one, self-type. Because the self-type is actions module with helping module. Actions module sort of with helping module, right? So it's this with helping module. So only if you do both, only then this will compile, which is a really, really cool trick. And the really awesome thing about this is that over here you can actually have cycles. So if you go back to helping like this, right? So instead of extending the actions module, we can do this. We can use the self types. By the way, they're called self types because, you know, because of this self type, right? It doesn't matter if you use self or this, it really doesn't matter, right? So now all of a sudden this is going to compile, right? And we don't need this. So now we have a cycle, right? And let me enable everything again over here, like this. Everything works, right? And we can also try to call the, you know, the demonstrate thing, right? So let's do a print line over here. Let's switch back to running, and we can print out nouns dot. Oh, actually, it already is doing print out for us. So let's do animals dot demonstrate like this, and now let's do nouns dot transport dot demonstrate, right? An empty line. Let's do verbs dot actions dot demonstrate, and the same thing with helping dot demonstrate, like this. And if I did everything right, then it should compile and it should run, right? It's doing exactly the same thing. Everything works. So there are no endless loops or something like this, right? All right, so let's talk about some details. So firstly, I cannot stress this enough. This has nothing to do with inheritance, okay? They sort of look like it, but, you know, because eventually you will have, you will have to assemble this whole thing, right, with a construct that looks like inheritance, right, but it's actually mixing composition. And having said that, let me show this to you actually. So let's say over here we wanted to print out eating, right? If we go to actions and we have this eating here, for example, right? So even if you do something like this, protect it to the actions module, right? Like this, then it's not going to compile, right? It's not going to compile because, even though, everything is mixed together, protected means if you extend actions module, right? And we're not extending actions module, so to say. All right, let me revert that. So what we're gonna do now is basically I'm gonna go back to this. I'm gonna comment. I'm gonna close all the other tabs, and I'm actually gonna throw this out as well. So what we're gonna do now is we're gonna play with a different example, just so that I can demonstrate to you a little bit more that inheritance and self types, they sort of look the same, but they're not the same. So we're gonna have a different example. So we're gonna have trait common, right? And we're gonna say show common thing like this. And we're just gonna print out common thing. What's happening? Common thing, right? Like this. Okay, so in the first version, what is happening? First version, like this, right? We're gonna use inheritance, right? So we're gonna say instance common, right? And we're gonna say show first version thing. Let me scroll down a bit. Unit is going to be so first of all we're going to show the common thing, right, because we're inheriting from it anyway, and now we're going to say first version thing. Okay, and now I'm just going to copy that, and I'm going to replace first with second, right, second, and over here we're not going to extend common, we're going to use self types, right? So we're going to go here, we're going to say this common self type, right, like this. Let's see if it compiles. Okay, it already compiles, right? Okay, so we're gonna go down here and we're gonna create two objects. The one for the first version, we're just gonna say extends first version, and we're gonna do object second version extends second version, and it's going to force us, right? So let's see if this compiles like this. It shouldn't compile, right? Because it should force us to mix in the common as well, right? So second version says, hey, whenever you mix it into something final, you should also mix in the common, right? So let's do with common. All right. So now over here in our main method, we can do show first version thing, right? Print line. Second version, same thing, show first version thing, right? So everything, what's happening? Oh, second, like this, second. There we go. All right, so now everything seems to work, everything seems to be the same. And this is like one of those things where people confuse, inheritance with subtypes, sometimes because, because what you actually have, in some occasions is that you can exchange them, right? So sometimes for some situations you can use either of them, right? The next thing that we're going to do is we're going to play around with inheritance. Let's see what happens if in the first version we go here, right, and we override the show common thing, right? So we're just going to override it. I'm going to say print line common thing from first version, like this. Let's see what's happening. Okay, now it works for this one, right? Let's try to do the same thing over here for the second version, which again is not inheritance, right? Let's see what's gonna happen. Okay, so we see some weird errors, and in fact let me actually do this and do that, and let's switch to more hyphens like this. Okay, so now you see this object SV inherits conflicting members, right? So object SV is this one. It says it inherits show common thing in trait second version and in trait common. It says this can be resolved by declaring an override in object SV. First of all, sure, this can be resolved like this, but this is actually not the correct thing to do. What you should do is you should change the order. You should do common like this, second version like this. Right? So now it works. So this is one of the gotchas that you need to know about the self types, that the order matters a lot, right? But let's for now pretend that we don't know this, and let's actually do this. Let's introduce the mistake again, so to say, right? And let's let's see, let's take this one. And by the way, I copied it. It should be like this, right? Let me duplicate this line. Let me let's try to do what the compiler is telling us to do, right? Like this. Let me scroll down a little bit. Okay, over here, and we're gonna say print line ignoring overrides is cool, I guess. So we're sort of ignoring, you know, the override that is happening over here, right? This one, common thing from second version, you know, we're still not going to see. So we did what the compiler asked us to do. We did it, and you know, now we sort of have predictable behavior, right? So this one is running now, but this override was completely ignored, right? In fact, the compiler doesn't, you know, ignores the keyword override, right? So if you have just def show common thing, it's going to be exactly the same thing, right? Let me put it back in. In fact, let's actually try to go to the second version over here, and before we are printing out ignoring overrides is cool, I guess, let's also see what is going to happen here. Show common thing. Like I would expect that the show common thing, you know, that you know, this one would run, but it's completely ignored, right? So it just says common thing, which is, you know, the common thing over here, right? And since we're already talking about super, let's do this in the first version, this one. Okay, so let's see, first version, override def show common thing. So before we print out the actual new behavior, let's also call super, right? So this works. This is the super call. So this line is over here, this one, right? This is the next line, and then we see the first version thing over here, right? Let's do the same thing over here, right? And this is not even going to compile, right? Because it says super is not a member of any ref, right? Because this here, what it actually is saying is extends any ref, right? So this is exactly the same code, right? So these are like all the differences between, you know, inheritance and self types, right? So let me revert this back to this, and so at least for now, like one gotcha you already know is that, you know, if you're doing something with self types, you really have to make sure that the order in which you mix things in works, right? Because you don't have all of these issues if you actually you know, if you actually do this. Let me remove this example, and let's have another one in which we're going to talk about this those cyclic dependencies, right? Let me remove this. So what I want to have is I want to have a trade chicken, and it's going to depend on egg, right? This is also another way to think about this. It basically literally means the chicken depends on an egg, right? And the same way before, you know, animals, you know, depends on transport. Okay, hold on. In the animals, we didn't use packages, but like in the other one, the actions depends on helping, and the helping depends on actions, right? So they're sort of like one thing. Self types are very commonly used if you have like a class that is sort of getting like too big, right? It's just getting too big, and all you want is to split it into different files, right? That's all you want. There's no inheritance. There's no like deeper meaning in this, right? There's also it's just a way to split it out in different files and, you know, assign them to different developers, and then this way you don't end up stepping on each other's feet, right? So over here in the constructor, we're just going to print out chicken, right? And now over here we're going to have egg, which is going to be basically diametrically opposed, depends on the chicken, print line egg, right? And over here we're going to have, again, the order matters a lot. First chicken, then egg, extends chicken, and then egg, and over here first egg, then chicken, extends egg with chicken, like this. Okay, so it should compile now, and now we're gonna run just the constructor, first chicken then egg, and over here we're gonna print out first egg then chicken, and let's see. It should be very predictable, right? So first chicken and egg, we see the chicken, and then we see the egg, and then we see the, you know, the actual toString of this object, and then the other way around. But check this out. What if we're gonna have a def over here? We're gonna say call it on chicken, right? And then prints out on chicken, right? And over here we're going to have on egg, like this, right? And over here we're going to call it, we're going to call on egg over here, and we're going to call on chicken over here, right? So pause the video, look at this, and tell me how this works, because I don't know. it's really funny. So basically, don't use constructors for lifecycle management, right? So if you want to do cycle management, then introduce a trait like this, for example, and do something like lifecycle, right? And over here, do something like on startup, abstract methods, right? On startup, and here on shutdown, right? Something like this. And instead of using constructors, so instead of calling on egg and the constructor, call them over here, right? So make the chicken and make the egg extend lifecycle and so on, right? Let me remove that like this. By the way, in the previous example, I sort of forgot to mention that where the order mattered, right? In Scala 3, which is also called, which is also known as dotty, which should come out somewhere in 2020, I guess, which is like a few years from now on. What they have is a thing called intersection types over here. I'm gonna leave the link down in the description. So what you can have is, instead of saying A with B, you can say A and B, and the idea is that the and is going to be commutative, right? So A and B will mean exactly the same as B and A. So I'm not really sure based on this if it will be possible to do what I think it will be, but maybe just maybe there won't be any difference. I'm sorry, I removed the previous example, but basically maybe there will be no difference between extending common first and then first version, or extending first version and then common, right? And this would be, this would make basically it would make a better case for self-types versus inheritance. All right, so we've seen how traits might be used instead of packages, but we haven't really seen why one would want to do that, right? As I mentioned in the beginning of this video, for this we need a bigger boat. So let's just patiently wait until I make the video about the cake pattern. For now, let me just walk through a list of small gotchas. So you already know that you need to be careful with cyclic dependencies and with the initialization order. The second thing that you need to know is that the Scala compiler hates cakes, right? It takes forever to compile cakes. What are my neighbors doing? The third thing that you need to know is that even though it gets better over time, you might actually run into Scala compiler bugs, as we've seen before. I'm sorry for this, guys. All right. The fourth thing is that you also might run into issues with SBT, right? Because SBT has this thing called zinc, which is a name for the incremental compiler. I'm not sure if you noticed in all of these 20 plus videos, but if we if I change only like one thing, the SBT only recompiles what's necessary. So what was happening in the past was that sometimes, if you use the cake pattern, that SBT would not notice that things changed, and you would end up with like stale files and weird things. That your code will compile, but it would have like a completely different behavior. It was really crazy. Now it gets better. The fifth thing is, we haven't talked about this in this channel, but Scala doc or Java doc, which is a way of writing documentation. So basically, you can annotate your traits, your classes, your objects, your methods, with everything, with comments basically, and then you can generate documentation. It works way better with packages, right? Just so you know. And the sixth thing is the any-val optimization, which we haven't talked about in depth, but basically any-val optimization, you can't have it inside of traits or classes. Let me actually show you this real quick, because it should be really fast to demonstrate. So if you have a case class, for example, meter, and it has a value, which is an integer, right? And you extend any val, right? Like this. So everything's going to compile, but as soon as you move it into a trait, for example, then it's going to say, hey, value class may not be a member of another class, which is really unfortunate. I wish that this limitation was removed, but it's probably not possible. All right, I showed you all the tools, but it's essentially your decision. Do you want to use traits or do you want to use packages? All I'm asking you is that you don't make this decision too quickly before you see the video about the cake pattern, which I can demonstrate the actual benefits of it, right? All right, that's all I have for you today. Like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.